Now, it's my pleasure to introduce our speaker. Dave, would you like to show your smiling face there? There we go. I'd like to thank Dave Cooter for being here with us today. Dave leads Deloitte Consulting's U.S. Cognitive Insights and Engagement practice, which is focused on helping clients establish their artificial intelligence capabilities and deploying a variety of AI and machine learning enabled solutions, as well as conversational AI, across all of their industries and sectors. He spent the past 3 years standing up Deloitte's U.S. intelligent automation business and, from an industry standpoint, is focused on helping improve core underwriting and claims operations in the insurance industry. Turns out that financial services, in many ways, has been leading the charge in this space. Dave holds a Bachelor's of Science in Electrical Engineering and received his MBA from UNC Chapel Hill. We're looking forward to hearing his thoughts on AI and the state of play across industries today. We're excited to welcome Dave to the RBS Executive Education faculty, where, not surprisingly, he will be teaching in a new mini MBA program on the topic of artificial intelligence. Dave, happy to hand things off to you. Thank you.
Awesome. Thanks, Margaret. Thanks, Emily, and welcome so much, or welcome everybody. Wanted to give you a bit of an overview of how we were planning on spending the next 45 minutes. There were two general topics. Wanted to spend the first half of our hour talking about a useful way to frame up the conversation around artificial intelligence. It's a buzzword that you see everywhere these days. News articles, publications, likely talked about in many of your organizations. Wanted to try and distill that to some of its main points so you can kind of see the forest through the trees and offer up a couple of useful frameworks that we have just for understanding what it really means and what's going on. And the second half of our hour, wanted to spend time just talking about the state of play in the industry, give you a feel for what we're actually seeing out there, what we're sensing from overall executives, in really what people are seeing as challenges, benefits, and what's actually happening in the market and likely at many of your organizations today. But hopefully this gives you a feel for what others are seeing and doing and just more broadly. Not intending to get technically deep in this session, much more business user focused and offering up again, terminology, ways to think and talk about this that likely are occurring, especially for some of your colleagues that might be less technical, less deep in the space than many of the attendees today. So I wanted to start off just the topic of what is artificial intelligence. So what you see here is actually the definition if you were to take a look today on Merriam-Webster. So the capability of a machine to imitate intelligent human behavior. What's important about this definition for AI is it changes. So the definition of artificial intelligence today is not going to be the same as what it truly means 5 years from now. And it's not the same as what it meant 50 years ago. To give you an example, those who've had the benefit of seeing the movie Hidden Figures with Kevin Costner about NASA back in the 50s, they had a concept there of human computers. They were referred to as computers, but it was individuals that were performing mathematic exercises for the NASA shuttle launch. Back in the 1950s, the scientific calculator was artificial intelligence. That was a machine imitating intelligent human behavior at that time. Today, we would not consider a scientific calculator to be AI. There's a host of other capabilities we'd be thinking about in 5 years from now, 6 months from now. Some of those may be different of how you think about AI. So that's the most important thing I want you to take away is the underlying aspects of AI are changing, which is also what makes it so difficult to grasp because it's constantly evolving. I want to give you a view across what you see here is the machine intelligence spectrum, and perhaps a way to think about it. In the basically horizons you see here evolving out from the lower left-hand side to the upper right are what I'd like you to take away. And this graphic shows on the left-hand side the y-axis is the level of human touch, going from high human touch in your left-hand side to very low human touch at the top. And on the x-axis, you have task complexity here, which is very simple tasks to much more multivariate, more complex tasks. And to give you an idea, like starting up machine intelligence at its basis, and really where we see a tremendous amount of activity right now, a lot of folks have heard about RPA, or robotic process automation. In a way to think about this right now, and a lot of the use cases that you see out here, I think of RPA as the last mile of integration. A great portion of a lot of RPA or automation that's taken place today is really focused on the integration between systems with humans that humans are doing today that your broad enterprise systems haven't had a chance to accomplish. And it's because you're getting to the point where the business is so complex, so different, it didn't make sense to integrate it in the traditional sense. And robotic process automation is providing an opportunity to do that, integrating between applications such as Excel, email, and your core systems. That's where a whole lot of robotic process automation is taking place today. And then as you start to move up the curve here to the right, you start moving into intelligent automation. And a way to think about this is augmenting or adding on capabilities to your base rules-based RPA. One of the most common ones we see are starting to bring in optical character recognition and more text analytics processing to augment your automations to make them more capable and take on tasks that they otherwise wouldn't have been able to do, which requires, in many cases, some interpretation, beginning judgment. Now, when you move up into the spectrum to the next on cognitive analytics, this is where you are starting to add in AI capabilities, which we'll talk a bit more about later. This is starting to move beyond what we see happening in years past of base predictive analytics and prescriptive analytics to start bringing in more of these artificial intelligence-based capabilities, such as speech and image recognition, computer vision, sentiment analysis, starting to add those to the mix. When you get to narrow AI, as you start to move up the horizon here, think of this as starting to add on those capabilities together to really start executing very narrow tasks. And that's really the big difference between narrow AI and general artificial intelligence, which is think about your Amazon Echo and your Alexa. It's got different skills. A lot of those are very much considerable for narrow AI or artificial intelligence, very good at conducting a very specific task, such as playing a song, such as letting you know what a sports score is or what the weather is. Very good at interpreting language and being able to execute a task in that area. However, once you start moving into multiple tasks or different types of tasks, you realize each one of those right now are separate skills that need to be assembled and added on. That's the distinction there between general AI. And I don't want to confuse the spectrum with where you see it, where at the top, singularity. Sometimes this spectrum gets confused and people think about artificial intelligence as with what I refer to as artificial superintelligence. And this is where computers eventually would be able to learn and improve over time to get to the point where they're exceeding what human intelligence is today. And that's something that we don't see in the next couple years occurring, but over the course of time, that's where you hear, I guess, doomsday scenarios around AI. We're both a ways off there from that occurring, and it's far up to the right when you take a look at this spectrum here. I also wanted to introduce this AI landscape, and this is also an easy way where we can think of where there's a lot of concern in industry related to the impact of artificial intelligence on employment, on jobs. And I would offer up, this is an interesting way to think about these horizons here within AI. The first horizon one, this is assisted intelligence. So it requires human assistance interpretation to actually do the work. An example here that many are familiar with, if you think about where a human is required, is think of cruise control in your vehicle would be a simple example. Humans absolutely required to basically interpret that data and make sure you don't hit the car in front of you. Been around forever, but yet you're leveraging a computer to basically automate some tasks that are there. Horizon 2, this is augmented intelligence. So this is where machine learning is augmenting human decisions. You see this in a lot of consumer applications today. A simple parallel here on the automotive side is this is where you start getting into lane detection, where you start interpreting images that are coming in here to understand if you're actually going out of the lane. It's your next level or your next horizon of engagement of AI. And then Horizon 3, this is autonomous intelligence, where AI is deciding and executing autonomously. This is where you're thinking about self-driving vehicles that occur across this spectrum. And you see a lot of organizations right now are really sitting between Horizon 1 and Horizon 2. Internally and externally facing, you see a lot of activity in the marketplace around this Horizon 2 of how can you offer products up to consumers and businesses where you're really instilling machine learning, which we're going to talk about in a second, into your applications. The four things you see around the bottom, these are really the enablers, are what's making this possible. The explosion of data and the exponential computing power being the two largest ones. It's often stated that a lot of the algorithms that are being used today, very similar from the algorithms that are being used 30 years ago. But the data that's used behind them and the computing power that's able to be applied are really the big differentiators. And I don't want to take away from the fourth here of the human-machine interactions. The user interface to be able to provide accessibility to users for these algorithms to train data has been a big advance in the last several years. You could argue even in the robotic process automation or RPA space, that itself is one of the biggest differentiators there. To give you an idea of these three horizons, we talked about consumer vehicles. I wanted to give you a business example across these three as well. One example would be in the claims adjudication space, for example, in the healthcare industry. For years, we've been able to automate the adjudication of a subset of claims that follow very straightforward business rules. That's Horizon 1. Horizon 2 is now starting to add in clinical and utilization data to determine which claims need to be reviewed. And that's where you're starting to bring in more artificial intelligence-based capabilities, more machine learning-based capabilities to process those claims. And where you get to Horizon 3 is this is where you're able to pay and deny all claims based on the intelligence that's there. You don't have any referrals over to humans, but now you've really hit Horizon 3 where that actual activity of paying or denying across basically incorporating a ton of judgment is able to occur, and that's in Horizon 3, where you're effectively replacing human judgment in processes today that have some ambiguity. I wanted to start, so two things that often get talked about, and I'd say are often interchanged that are different I want to start with is machine learning and artificial intelligence. Two very different things, where artificial intelligence is changing year over year, the underlying definition. Machine learning has a pretty solid definition that stays stable over time. And this is the ability of an algorithm to essentially program itself. And what you can see here is that traditionally in programming is applied to the point you basically have an input and then you apply some rules or programming constructs to get your output. However, with machine learning, you're taking an input and an output, and you're automatically identifying those transformation rules, which has tremendous advantages in an algorithm being able to train itself and to learn and improve over time. One of the things I would highlight here on the machine learning space that I'd say is often confused. We think about self-learning and the thought in business is this is great. I'm going to automatically learn and adjust my business processes based on what I'm hearing from customers. There's a huge dependency in machine learning to your underlying business process. One of the examples I often use is, let's assume you could come up with the perfect algorithm to hire the best individuals into your firm. Well, this is great. So I implement the algorithm, and today I apply it, and I have a good understanding. It's got a recommendation whether I should make a hiring decision or not. Perfect. But when does that algorithm get better? Well, it turns out your business process related to hiring, let's say the first evaluation you're going to do is 9 months from now. So it's not until 9 months from now that my algorithm is going to have an opportunity to get smarter or learn from its actual decision. So that's where, again, I'd highlight on this machine learning spectrum, it doesn't necessarily mean immediate tremendous dependency on your business process. What you see below there is also you hear a lot of concept of training, like how is the machine actually trained, which is a core element of any machine learning algorithm. Three basic types here, and I'd highlight here with a simple example. I'm going to oversimplify this there, but one that everyone's familiar with. Anybody who's used Picasa or way back in the day, I'm probably dating myself there, or for example, Apple Photos to leverage the facial detection. There would be three essential ways you could go about this. I'll start with the one in the middle, which is unsupervised learning, which essentially means you are using untagged or unlabeled data. How would you get the facial recognition to work? Let's say you had 10,000 photos, you input them into the program. What would it do? Without you having to do anything and using object detection, it would sort those photos into faces that looked alike. Had no way of knowing who was who. That is unsupervised learning there. You didn't tell it, give it any information. It just arranged very like faces together. A business application for unsupervised learning where it's often used is in customer segmentation. So you've got to identify very like customers. You know nothing about them. The computer would be applying this algorithm to categorize like customers based on a variety of data types. But there's another way you could have assigned that data or gotten the computer smart. You could have trained it. This is what happened way back in the day before facial recognition existed. You manually went through those 10,000 photos and you identified the individuals that were in each photo. You were going through and you were labeling, basically applying labels to the data, so that the first time you uploaded it into Picasa or Apple Photos, it was then working with labeled information. So the next photo that you input, it had all this labeled data to make a better prediction on who the faces are that you're entering in. In the last one, reinforcement learning. So imagine this was the third type and you were starting from scratch. You input your first photo and the machine makes a guess. It's going to guess Dave is the person. It's almost irrelevant. You're going to go through and correct that prediction. You say, nah, that's not Dave. That's my sister Barb. Perfect. Then you enter in photo 2, and then you're going to progressively name, and eventually the machine is going to get smart based on your ability to label each as it's coming into the system. Eventually it will know your sister, it'll know your father and your mother as it sees more photos, and you're doing it iteratively. You're training the algorithm or punishing the algorithm. But three fundamental ways here that you actually train these algorithms to get better. And I hope the thing, especially on supervised learning and reinforcement learning, starts to increase is, wow, the tremendous amount of data that you need to get these algorithms to work correctly. To give you an idea or an anecdote, like Facebook, when they processed some of their early facial recognition software and started to train it, they used 4 million images across 4,000 individuals. That was labeled information, or about 1,000 examples per individual is what was required to start to get the algorithm to perform correctly. So you're absolutely, in many cases, talking in thousands, hundreds of thousands, millions of lines of data to get some of these algorithms to hit levels of accuracy that you need to be successful. And we'll talk about later how this is one of the larger challenges for implementing these algorithms in practice in the business world, is getting your data in order to make it successful. So I want to offer up, as of today, we talked about how the definition of AI is changing or is very temporal. You see here, I'd say 9 core capabilities. There's some others that you can be fairly confident in 2019, February, reflect AI or reflect intelligent human behavior. So the first one that I'll provide, speech voice recognition. You're very common with this. It's embedded in a lot of consumer applications today. Your Echo, your Siri, your Luis, your virtual assistants. If anybody's had the opportunity, one of my favorite examples here is the Google Duplex example. Those who haven't had an opportunity to look at that technology would encourage you to do a Google on it afterwards and look at Google Duplex. It's a 5-minute demo But in about 2 1-minute calls, they demonstrate the capability of voice virtual assistants that's really hit the next generation. You can tell the users that are interacting with the virtual assistant can't tell that they're interacting with a human. There's a couple, I'd say, almost magical elements to it that I would highlight for you or ask you to focus on when you do listen to that demo. One, those calls are outbound, and it was not self-evident of why they would choose outbound calls in the outset. And why they've done that or used that is it turns out outbound calls in the business process are much easier to dictate or constrain. You're the person on the offensive. You're not responding to a variety of different inquiries. Much easier to program and to anticipate how a user is going to respond. So that was one of the areas there that makes it so successful. And the other thing I would encourage you in about a conversation where a virtual assistant is so magical here in about 50 seconds, to notice the amount of ums, uhs, pauses that are inserted. These are things you never hear from your Siri or your Echo and your Alexa that are innately human. And those absolutely were inserted in and add to the, I would say, the magic that technology is able to display here. And what's great about this is when you take a look again, realizing how really close we are to replicating that human experience. On the second side, if you move over to the right, text analytics and NLP. This is very commonly being started to use in business processes here, and I would say one of the most common applications that we see it in here is data extraction or cognitive data extraction. So oftentimes many forms, many applications, submissions that you get in a variety of business processes, you have very structured information and then you have unstructured information. And it turns out the back-end business process to actually move the item along might actually require you to make an interpretation here. And often when I use in the insurance space that I work in is on the claim submission. It turns out you might receive a lot of information or claim submission in email. And right now you have a lot of people that are responsible for just basically moving the claim along to the next step in the process. Some of the information is very structured. You might have a claim number, you might have a policy number. You can extract those pretty easily. But then you'll get into things like, what's the loss type? Typically when somebody's filing a claim, that'll come in a descriptive element. Well, my basement flooded. Well, the other end of the process just says water loss. So the interpretation that my basement flooded, or a variety of ways that could come into a water loss, is leveraging text analytics in natural language processing, or NLP, to really move that along. The next one on the right, automatic decision management. There's a slight difference between this and recommendation engine, which shows up in your lower left, but automatic decision management is starting to automate processes here. And one of the very common ones that you might be familiar with is like a pricing engine. So when you're seeing differentiated prices based on unique aspects of the users, a lot of times artificial intelligence sits behind there. But this gets into actually making decisions based on trained information. On the sentiment detection side, this is the capability of computers to actually understand how you're feeling on the phone, whether you're angry, whether you're sad, and to be able to start adjusting. You can imagine by being able to interpret that, you can adjust things like how you're actually proceeding in a conversation. Sentiment detection also would be the core, if you can imagine, in any future applications related to negotiation or being able to handle what right now humans are doing. Sentiment detection could allow you to navigate those conversations based on actual emotion. It's also being used to understand the level and the quality of customer service that's going on today, and could be done in an automated fashion across tens or hundreds of thousands of calls. On the biometric side, this is gets into being able to authenticate a user based on physical characteristics. A usage that everybody's familiar with is just Face ID on your iPhone. But one of the more common business challenges here, I would say, it has to do with your service center and your sales organizations, their call centers. If you take a listen to a lot of your calls today, anywhere from 10 to 50% of some of your call lengths are actually having to deal with authentication and being able to identify users. It's actually one of the areas that's still one of the most difficult things for speech and voice recognition to be able to do effectively. And it comes in authentication. If you can imagine, it's kind of easy to play a song because there's different ways or different sounds people pronounce for different bands. But now when you come into trying to interpret names and addresses, the millions really of variations of some of those, and being able to get it accurately. If you think about even your own personal experiences with call centers, when you call in and you try and get you offer up your name, how often do you have to spell out your name so the individual on the other line knows it? And I'd offer up, if it's difficult for a human today, it absolutely is difficult for a computer. But we are much less forgiving in those processes of a computer having an error than we are for a human. But this is why biometrics such as voice identification, being able to identify a user based on the quality of their voice, their face, their fingerprints, are all very key capabilities that really are going to form the centering of enabling many future state business processes. On the natural language generation side, this has to do with areas like the common example for folks here would be things like anybody who plays fantasy football. You have examples such as overall your recap at the end of the week that's automatically produced. But a business example that you could think of is natural language generation would allow you to produce consistent feedback across large-scale operations here, whereas you might have a variety of, for example, supervisors and managers that are generating feedback based on their own impressions. Now with natural language generation, you're able to offer up consistent recommendations for for actions to be able to be taken based on data versus just presenting the data. Recommendation engines, very simple example here, you see it all the time. Amazon recommending a next best purchase, very common today. On the pattern and anomaly detection, most common example would have to do with cyber. And on object detection, this is the ability to identify images within vision. You see a lot of examples here within quality today and within indexing, being able to understand or very quickly identify something within video or an image to be able to search through and identify it. One of the things so we had gone out and taken a look at 200 companies out there to understand what were they really doing when it came to AI, and we identified a pretty simple formula. So after looking after every company that was out there, and we found out every company did one of three things. They did functionality, and it was to either inform, such as providing insights based on one or a combination of several data sources. And applications here would be clustering customer segments, evaluating customer behavior, predicting disease outbreak would be some examples. They recommended, so they're advising on appropriate actions based on insights generated from process data. Applications here would be suggesting new products, prescribing medical treatment plans, guiding customers through the product selection process. And the last is they were helping you decide, and this is actually performing actions based on data. So common deciding applications such as adjusting prices in real time, sending emails to customers, scheduling meetings, transferring money. Each of these companies did it based on data. There's 4 different types here. They're doing it on company data, product literature, manuals, guidelines, procedures, journals, best practices. They'd be using public data, Wikipedia, census data, industry definitions. Regulatory data is a very common and oft-used data source that not many are using today. Third-party looking data sources that you purchase, or customer data. And customer data would be things like feedback data, smart home data, driving behavior data, things that your customers are offering up, likely as part of their relationship with you that they're basing it on. And it was done in order to address specific needs here. In 3 primary buckets of needs. On your product side, AI applications are being used to improve your offering, such as, is it adequately fulfilling the needs of customers? Is it personalized? Is it available at any given time? Used to lower costs, such as eliminate labor. Convenience, it's intuitive interfaces here, flexible, privacy, fast product delivery on the product side. It's being used to improve communication on your channel. Are you able to do this any channel, anytime? Increase the number of touch points that you have with your customers. Increase problem solving, being able to proactively identify what a problem is and being able to resolve it. And just increasing the timeliness of responsiveness and help. And then the third, on your operations side, this is really driving your efficient use of processes as well as resources, reducing the need of resources on your internal operations side. And there was, the last I would highlight is just this overall matrix in terms of how value is derived. And we see a majority of companies today sitting down in this, what I'd refer as replacing known actions on operations efficacy and customer efficacy. On the ops side, this is the ability to produce intended answers or actions that serve to improve the speed and accuracy of internal processes or decisions. Examples here would be customer service automation or fraud detection, basically improving your bottom line business results. On the customer efficacy side, these are applications or AI applications that are used to produce intended answers or actions that serve to improve customer loyalty or conversion. These are your recommendation systems, your pricing automation. On the top side, this is discovery. So this is looking for novel answers or actions that serve to either improve your internal operations or your customer loyalty or conversion. An example on the customer discovery side that a lot of folks are familiar with, and because they're making a ton of hay in the market, is Netflix here. This is not how they're actually making recommendations on your next best movie. It's how they've been using that information that you've come up with over the last decade or so to generate new content. They are able to identify new customers based on existing or their history of selections of what they'd like. It's a really remarkable use on the customer discovery side. On the ops discovery side, a very primary application we see today is on the quality area or aspect. So you see a lot of manufacturers being able to aggregate a tremendous amount of data to identify unknown problems earlier within their manufacturing process or supply chain. And on the known side, those are the common applications you're well aware of. On the efficacy side, again, think of your recommendation engines. On the ops efficacy, think of intelligent automation and really moving to improve your bottom line here. Say we're about halfway through the hour. I just wanted to ask Margaret, I didn't know if any questions have started to pop in on the line, or if it makes sense to answer a couple of things that have come in before we move to the second half.
Yeah, if you don't mind answering a few of the questions we've received, I'll start with a request to provide a use case for implementing machine learning in accounting and the financial services area.
Use case for AI in accounting and finance. Example there, some of the ones we see, and this is going to seem fairly basic. Invoice processing, been around forever. You can do some basic stuff, but then when it comes to, you're starting to use absolutely text analytics there to start to extract information off of your invoices and get them into the systems automatically, or get them into your systems automatically. Very common one, and that's starting to move to the next level that we see organizations challenged with. My favorite story there is one of the organizations I was dealing with. Their biggest challenges on matching invoices actually came from their internal business units, not their external suppliers. So it was actually getting their internal business processes in order to be able to match things appropriately there. Less so on their suppliers' side, which happen to be very compliant. So that's an example on that side. Next question.
That's great. So William asked, or said, obviously AI will be a powerful tool for all future businesses. How can business students better position themselves to manage AI systems and or help companies transition to AI software?
The example there, and we've got a framework which I could go into with more time of Tom Davenport, one of our SMEs, has come up with a great lecture. But basically, getting access or spending time on your raw STEM capabilities, and I encourage. It was a recent partner of mine where I was so impressed. There's a lot of avenues out there for self-education, Coursera, and so on, to actually get enough exposure to the topic at a technical level of detail that allows you to make decisions. Does it expect you to be the person that's going to have hands-on keyboards at the end of the day? No, but it is going to get you familiar with likely the capabilities that are out there, how it's being applied, and much more conversant. And I think the individual who had taken it's a Stanford course that's offered that's really great, taught by a preeminent lecturer there. It was about 80 hours, of course, several weeks, and I would absolutely encourage many business students to be spending their time the same way, just to familiarize with their topics and make themselves conversant, versus telling everybody to go out there and get another bachelor's degree if they happen to be a liberal arts major, and absolutely is gonna help them move the ball along.
Yeah, it sounds like lifelong learning, which is what we're encouraging through our webinar series. So that's great. So I have one more here, um, and that is a question. Are there publicly available guidelines or sources for scripting? Wait, let me try that again. Scripting very conversational, plain language AIs such as chatbots.
That this is where you see, I'd say, a lot of companies, service providers, and so on having to build some of that. Where you get some benefits is from some of the organizations that have been at this for a decade or two, having some of those in there.
Okay, great. We do have a couple of
I would
more.
say it surprises. Oh, sorry. Yeah.
Please finish. Sorry.
Oh, I was gonna say there is so a lot of sources out there, but I think you'd be surprised for some of the basic conversations how you're likely preparing a lot of those interactions or utterances and intents and responses for your specific business processes. So a lot of that is a little bit bespoke today, unless you're building off of a customer vendor that actually has delved into your very specific business process before.
Okay, great. We do have a couple of more questions coming in, but I wasn't sure how many you wanted to address now and others that you might want to save for the end.
I've got one more. I've got
Okay.
time for one more, and then we'll go through and we'll circle back.
Okay, good, good. So next on the list was, I believe it's a reference to something you talked about earlier, and it says, "Is Netflix monitored?"
Is Netflix monitored? I was going to say, I have not worked specifically with Netflix myself, so that's something I couldn't answer related to overall monitoring of their algorithm. So
Um,
I am aware of Netflix, much to the extent of likely many of the folks on the phone, unless you happen to be working there yourself.
There was a follow-up that might put this question in more context, because it says monitored by Nielsen or a third party, and the person who sent it said they're curious because of how much the markets rely on their metrics.
Yeah, not aware. I believe a lot of the data related to Netflix is proprietary. So, I mean, that's something where if you ping me offline, might be able to understand with some of our folks there. But I'm not aware that Netflix, for example, has any, or sorry, Nielsen or anybody's got any access to data there that's not publicly available.
Okay, good. So for the other folks who have posed questions, we'll address those as time allows at the end. But I do encourage people who have questions to continue using the questions box. And thank you, Dave.
Awesome. The next, I wanted to move into just a quick view of what we're seeing in the industry, or kind of the state of play. This reflects a survey we do now annually. It goes out to 1,100 business executives. This actually went out in August of last year, compiled and produced the results in about October. 60% of the folks that responded were at the CXO level across all of our companies, to understand where they're investing, how that's changing over time, and really what their experience is with AI. What I'd highlight here is you can see the significant increase, not only in use of machine learning, but also deep learning. Where I'd highlight there is it's interesting. It gives you insight into starting to move beyond processes that are pure in human interaction. Why is that? The big challenge traditionally with deep learning has been the explainability of algorithms, which is oftentimes necessary to incorporate it into a process. We've done a lot of work back in the day related to on the underwriting side, and that's an area where you need explainability both to the users of the AI recommendation. They need to trust it and understand, so many times they can explain it to their customers, whoever they're interacting with, why a decision is being made or recommended. And the second area is on the regulatory side. Especially in financial services and many other industries, you not only have to be able to explain to your customers, you have to be able to explain to your regulators why you are making a decision to ensure that your algorithm is not biased. In deep learning, traditionally obfuscates the explainability of why a recommendation is being made. So that's one of the interesting things here is what you're seeing by this increase is AI starting to move into more, I'd say, back office processes aren't customer facing into these areas that it hasn't been able to before. And on the right hand side, you can see the increase of computer vision, natural language processing. Don't be thinking about these as super advanced. I mean, one of the biggest examples of computer vision is, I mean, the US Postal Service interpreting handwriting results on your envelopes to be able to automatically process and make sure your mail gets where it needs to. Computer vision is the technology behind handwriting interpretation. So you don't have to go out and be thinking about autonomous vehicles at that level here. I'd say companies are using this technology in more mundane and basic ways. Second question had to do with AI investments paying off. You can kind of see a differentiation between industry here. What I'd highlight is the two industries on the industrial product side, and I'd say I think technology is really what's driving the higher investment ROI there. These are industries that I tend to see are starting to put their investments in AI more on the product side versus the back office side. And that's where you're starting to see the higher ROI, but also the higher investment being used to generate revenue versus reduce costs. And you can see a lot of professional services. It's where you got a lot of InsurTech technology companies really on the services side coming up with very unique solutions. That's where you see them there up there. And then financial services, consumer products, life sciences, absolutely high investments in these. You see a lot of these organizations on, I'd say, a mix of front office, product based, as well as really starting to explore on the back office side as well. Other thing I'd highlight here is you can see the average return that's being reported. We'll talk about later on is like one of the biggest challenges I see just has to do with expectations. A lot of times when you're starting to incorporate AI into the back office, especially when you're thinking about cost reduction, this is a different type of investment. It's not like AI is at the capability yet where you're replacing job functions here. I try to refer to it in business metrics of this isn't the kind of investment where you throw 100 million in and you get $1 billion out. This is the kind of investment you see here. You throw 100 million in, you get 120 million out or 115 million out. These aren't typically investments where even the timing with them tends to pay off in 3 to 6 months between when your cash flow outlay is. This is something that takes time to get the system up, get it running, get it incorporated into your business. You should just be setting your expectations there in many of these areas around, I'd say, much more traditional tech transformation. And then you'll be pleasantly surprised with the pace of the technology. And it's interesting, when everybody says, is the technology up to pace? Or is it mature enough? What I find is the underlying question here that's being asked is, what's the cost effectiveness of the technology is now versus can the technology do it? Because I think you'd be surprised about the capability of AI technology today. It's based on the additional work around it to make it successful. Next slide here, what you can see is this is actually showing you the switch, literally from 2017 to 2018, of the move from product focused to internal operations focused happened in that year. And that's the switch that you're seeing, which the top bar is where we saw enhancing current products was the focus in 2017. and it's reduced in 2018, and you're seeing a lot more focus on cost reduction, optimizing internal operations, and business cases starting to pay off here. A lot of this is due to RPA intelligent automation, believe, but it's also incorporating more advanced AI in those areas. How do executives view this? We see AI as being a necessity, not an option. This is how the C-suite is referring to it. 60% of them being used to catch up, stay on par, or edge slightly ahead. I mean, that's why they feel they need to be playing here. You see the top 40% there are really looking at it to widen the lead or leapfrog ahead. And I think you feel a lot of this from that technology space, industrial products, that side that's implementing it on the product side. Others don't want to find that several years from now, somebody's fundamentally ahead on the efficiency side and got a much bigger advantage they haven't been investing over time. This on the management side. This is also fascinating. I'd say this is a little bit of the come down from the hype cycle on AI. I often translate the results here. I think it's a Bill Gates famous quote of, we often overestimate the amount of change that can happen in the next couple years, underestimate the pace of change or the amount of change that can happen in 10. And I think you see the industry starting to adapt to this with these expectations here, which is transforming the whole industry down from 60% to 40% over a year. I think people are getting a flavor for the technology, the pace of adoption, and it's influencing their vision of how fast this is going to actually impact in those areas. And the second thing on the right is just measuring the KPIs necessary for success is becoming a much bigger factor related to overall, basically measuring ROI, project budget cost. This is as AI I see starting to move out of the realm of innovation centers in your organization and starting to move into the line of business. And we talk about that a bit, as I think that's sometimes a challenge there is looking at these investments correctly, but you're seeing these start to move into the line of business, being funded at scale, and a lot more focus starting to be pushed into the ROI, overall return on investment. Top challenges related to gaining value from AI. You see some of the biggest ones. Implementation tends to be the largest. Integrating AI into companies' roles and functions. Explainability would be the underlying evidence here. Can you actually explain to your users why things are being done the way they're done? Can you actually take advantage of the algorithms? One of the things that I find it's challenging, you are in a lot of cases taking advantage of the law of large numbers, which means on average you're going to be better leveraging an algorithm's output many times than human judgment. And one of the challenges many organizations face is, well, but I've got humans that are better in some cases than the computer, and they absolutely are. The challenge is if you start relying on human judgment, you start eating into all the benefits you have from improving there, because on average, some of the algorithms are going to be right more often than not. Data issues. I would argue this is one of the largest ones. We talked earlier about machine learning, the sheer volume of data that you need, but getting that data into the right area, thinking about data privacy, who you're going to provide access to data and how that's going to work. We see a lot of organizations, I say, if you're not doing anything with AI right now, where you can absolutely not go wrong in terms of starting to spend your investment dollars is getting your data arranged so you can take advantage of it in the future. So you can merge it, mix it, bring in alternate data sources, but really starting to get your arms around that so you can take advantage of these technologies later on. Cost absolutely sits up there. This is just the overall ROI and expectation setting. And then skills and challenges in measuring and proving the business value are a bit challenged, but I would say this is much more about the dynamics of where you're seeing a lot of investment take place here, is it tends to be obfuscated, either sitting in an innovation center, maybe being incubated in the technology side where it's not, doesn't have direct exposure to your lines of business P&Ls, where it tends to be challenging. What we see effective companies do. All right. So how do we see effective organizations going after it? So 54% of them created a process for moving prototypes in production. Can't encourage enough. We still see a lot of treatment of AI solutions exercise as much as they would standard tech implementation versus these concepts of learning, doing, getting it out there into production, and being able to learn from your mistakes. And this is where companies that we see being very successful on here have created a process for in a streamlined manner, getting stuff into production so they can learn and take advantage of that acquired knowledge. Looking at the implementation roadmap, this is, I would say, much more looking for a roadmap or a strategy versus a bespoke one-off approach. A lot of times companies are looking for individual use cases versus I see successful companies trying to take a look at a single process and the transformation there, not looking for the one-off best cases to be at, taking a look at individual processes and say, how can I really make a change in this across the board, and how is AI going to apply at many different areas of the process, not just, hey, if I go into one back office portion, I can reduce labor here. How do I look at my overall order to cash, my procure to pay process? We were talking about accounting and finance earlier. How do I look at those and apply AI across that process to really make a fundamental change? Appointing senior exec as an AI champion in a center of excellence. What I don't want anybody to take away from this means centralizing the AI capability. What we found interestingly here is AI is perhaps a little bit different than your base RPA. There's so many different applications, functions. You're not looking to centralize that capability, but being able to provide a resource across your organization to get the advice and the support you need in evaluating different solutions and figuring out the most cost-effective way to do things, I'd say is one of the most beneficial ways on having a company-wide COE. You'll get brought in a lot of different vendors, solution providers here that I don't want to say are providing things beyond what's able to be done. I find a lot of value in organizations from acquired knowledge in individuals that bring up creative solutions to solving some of those challenges we saw before. And then you see on the lowest end here is the comprehensive strategy for AI. Like, this is coming and evolving, so I expect this to start increasing soon, but don't think you need to solve world hunger or the entire organization's problems out of the gate. Cybersecurity, it's becoming a more and more top of mind, especially when you start thinking about moving things into production. Also, when you start thinking about things, we see a lot of activity in the marketplace now about the concept of, I'd say, citizen data science, or allowing my organization to start taking advantage of all of our accumulated data. Cybersecurity and staying top of mind here is a huge issue for organizations that they're starting to get on top of, and realizing I've got to be able to tightly manage access here, but yet permit access, so we can actually start taking advantage of the data we have and benefiting as an organization, so it's not super tightly controlled. How do I balance those risks and trade-offs? Use cases. This provides a view right here very quickly of where we see use cases and where executives are telling you they're using it. IT, quality control, sitting on that side, cybersecurity, predictive analytics. None of this should be surprising to folks that are focused in this space, but it gives you an idea of where individuals are actually using it. Then customer service, risk, sales, decision support, and way at the bottom, tax, audit, compliance, forecasting. These, I'd say, are some of your next generation finance and accounting. There was a question earlier on. This is where you see the AI being applied on those levels. And I'd say those are much more common for some base RPA versus generally being associated with bringing in AI into those areas. And last but not least, how are companies actually engaging AI right now? 60% using embedded AI within I'd say their core enterprise software. So think of your SAP Leonardo, your Salesforce Einstein. Those are the types of applications that they're starting to use AI here. 50% are using cloud-based services. These are your Amazon AWS, your Google Cloud ML, your Microsoft machine learning. Your cloud providers is another way to get easy access to some of these capabilities. You see a lot of companies right now leveraging partners or co-developing these with either partnering on the innovation side or partnering with services firms. And then you do see a lot of access to the crowd here, going after moving forward your AI initiatives by starting to tap into the crowd and some of the knowledge there. You'll see a lot of news or bespoke articles related to hackathons that go on. And what I really appreciate about that is organizations that are starting to leverage some of those their internal data and trying to solve really fundamental problems within the industry. That's really some fascinating stuff that's going out there. So Margaret, at this point, I think we've got about 6 minutes left, and I guess I'd say I'm happy to take questions for the balance of our time.
Great, because we do have several questions. I'm going to try and summarize some of the questions around legal. So there are definitely questions about law and regulation around the AI industry and R&D in the space, and then also some of the best courses to take to be up on this topic.
Perfect. Do you want to start with one versus the other?
Those were all kind of around the legal aspect. So the best courses out there to be current is definitely somewhere we can start.
Perfect. So best courses to take, and this is definitely something where you could get absolutely. So the Coursera course I was talking about, that was an Andrew, I believe NG. That's one of the Coursera courses on machine learning, which I think is a great course that's out there. Udacity has some courses that are very good. They've got a machine learning nano degree, different time that's focused there. You've got some ones that are very focused on finance and accounting. Columbia University has a AI MicroMasters. So there's a variety, I would say, of courses that are out there. A lot of these, I find, start to tend into the, maybe there's a minor cost for some of these to go after them. Mm-hmm. And there's also, I mean, what are you paying for there, I find? Somebody distilling complex information that a self-learner can often get off of, all right, could I download the R package or some Python and take some self-learning courses there, some freeware, using some open source guides, and kind of teach myself. So I don't want to point everybody to paid content there, because there is a lot of free stuff, but what you're paying for is elegant instructors that are exceptionally good at distilling complex information, so you capture the most from your time spent.
Oh,
so it's
great.
Excellent for executives. So a lot of questions you were asking around the legal side, ethics. Mm-hmm. What were the nature of some of those?
Regulation in the industry and around specifically research and development.
Regulation's evolving. As my experience has been with a lot of industries, you see a lot of the regulatory bodies working to catch up related to it. So you got a lot of organizations starting to push ahead here, and regulatory bodies trying to figure out how to react in many areas, which I'm sure a lot of them are top of the news. In the insurance space in particular, I'd say some of these are a little bit ahead, because AI and predictive analytics have been used for years. So explainability are things that a lot of those organizations are well versed on. But we see regulatory agencies just a little bit behind here, as everybody's aware with moderation, content moderation, for example. A lot of the search engines is a big one. Right. In the second half, Margaret, what was the second part of it?
Was about regulation around R&D, but I think you sort of touched on that it's really evolving.
That is the fair, and it's going to be unique to each industry, regulatory bodies in those industries that are going after it. And on the R&D side, like this is, I'd say the preeminent one where we have a tremendous amount of focus now is on the ethics within AI now. And really, how do you make sure, my experience has been that, and why there's so much focus on explainability, is you oftentimes, AI is identifying proxies for areas that have legislatively been indicated that you can't use these factors in making decisions. which is why it's so important to be taking a look at that and constantly have your mind on making things or looking at bias. And some of the, I mean, most recent articles, and it's been known for a while, is this is one of the benefits we've started to see of having diversity in your teams or in your organizations. The variety of perspectives in this AI space absolutely helps you start to moderate some of the behavior.
Oh, that's great. To be respectful of everybody's time, I'm just going to pose one more question, and maybe, Dave, if you wouldn't mind, we can share the additional questions with you and maybe come up with a blog follow-up or something great like that to continue the conversation.
Yeah, be happy to work through something like that.
Oh, wonderful. Well, I'll throw this last one out there, and I think that we'll all be able to relate to this. And it's, do you see consumers, that's all of us, being able to take control of their data in the future where they can sell it through a data marketplace?
Now asking me my opinion on the future for unknown. Um, I can see that having potential. Now, is it a centralized marketplace or is it through individual organizations that you would work through? I'd say the stepping stone I see to that is individual organizations, which they are implicitly doing today. You are essentially in return or bartering for a good or services that's being provided. You're essentially offering up your data today, and I could see that transitioning in the interim into maybe a more formal scheme in terms of a discount, or scheme isn't the right word, more formal contractual arrangements. And then I could see absolutely a third party attempting that or trying to bring it up or compensate. The question I guess always maintains, or one of the challenges there is, I think what most organizations find most valuable about us as consumers is not what we want to tell a third party, it's what we actually do. And one of the challenges for a third party is they're going to have access to what you choose to tell them, not what you're actually doing or the decisions you're making, which, again, many individual companies have access to. So I think that'll be one of the biggest challenges for a model like that.
Oh, that's great. So, Dave, thank you again so much for your time today. I also would like to, on behalf of myself and Emily and the entire team who's putting together these fantastic programs for our alumni base, we'd like to thank all of the attendees for joining and so actively participating in the discussion that we overflowed time. This is a friendly reminder to those of you who are interested in this virtual Lunch and Learn series that these are monthly events at which you can, and I'm using the air quotes that you can't see, meet us in the middle, meaning that they take place in the middle of each month, the middle of the week, and the middle of the day. For more information about the series, you can visit business.rutgers.edu/alumni/lifelong-learning. We'll also be sending information your way. We have an exciting schedule of topics and speakers in the coming months, but are also open to your suggestions. If you'd kindly stay tuned as the webinar closes, you'll receive a brief 3-question survey about this webinar that includes a free-form field to type in any suggestions you have on future topics. And as I mentioned earlier, a link to the archived recording of this presentation will be sent to you very soon. Thanks. Have a great rest of the day, and bye-bye for now.